Okay guys, day 11, here we go. Put some reggaeton. If you don't know what reggaeton is, you should look it up. It's good shit. So let's go to today's problem. Oh shit, it's kind of loud. Okay, now we're good. So problem 237, delete node in a linked list. So write a function to delete a node except the tail. So we can't delete the last one in a singly linked list, given only access to that node. Suppose the linked list is 1, 2, 3, and 4, and you are given the third node with a value of 3. The linked list should become 1, 2, and 4 after calling your function. So, just a quick reminder of what a linked list is. It's like an array, but for each node, so this is called a node. For each node, you have a value and you have a reference to the next element. So here they have a constructor where they have val and next. That's exactly what a node is. If you want to access the value, you just say, for example, node is a reference. Say node.val, you get the value of that node, and node.next, you get the next node. The first time I did this problem, I was really confused because usually what you have when you want to delete a linked list, you have two pointers that you create. You have a previous and a next, or a head. I'll use a head because next is used for accessing the next is like a inbuilt attribute for linked lists. So I would just use a head, but it's the same thing. So usually I have a prev and a head, and what I do is I do this operation here. So I say prev is equal to a head, so I'll delete this reference. That's what the first line is doing, so I'm pointing prev to a head. Let me see. Actually, what you're doing is just you're doing this. So disregard this. It's a head dot next. A head dot next. A head dot next. So what you're doing is you're getting the previous node and changing its reference from a head to a head dot next. And since this node here doesn't have anything pointing to itself, the computer will delete it. It will delete it from memory. So then it would be 1, 2, and 4, which is what we want right now. But the problem is that we're giving, according to the problem specification, we're giving just a reference to the third node. So here's 3. And instead of having like a way of accessing the previous element, you just have this reference here. And you wanna delete it. So we can't actually change the reference of the previous node and pointing to the next. That's usually the common operation when you're trying to delete a node. So this is confusing. So it took me a long time for me to realize what I had to do. But it's a very nice trick. So instead of changing references and stuff, that's what you would do if you had a previous reference. You're actually gonna transfer the next value to this node and point this node to whatever 4 is pointing to. So here 4 is pointing to none, to nothing. Usually it's represented like this, like a square. Okay. So you have 4 here, 3. We want to delete we want to take out 3, not delete the node. We want to take out 3. So what we're gonna do on a higher level, we're gonna delete 3. We're gonna copy whatever is next, the value that is next to it. So we're gonna put 4 here. And then we change the reference of this node to whatever 4 was pointing to. And since we stop referencing the last node, it disappears. So see, we got the same result we wanted instead, but not, we didn't need a previous reference, which usually would be the standard operation. Now we have 1, 2, and 4. So it's pretty, you only write 2 lines of codes, but having this insight of not of like just getting the next value, putting it into the current value and changing its reference, for me, I couldn't think about it. I had to look up at the discussion. Hopefully you guys, when you try it on yourselves, you guys will be able to realize this solution. But it's a pretty cool trick you guys can use. So what we do is exactly what I said. So node is the reference. So node is this, we're pointing to 4. Node.val, so the value at that node we are pointing to will be equal to the value of the next node. And then we change the reference of next to node.next.next. This will give us the reference that this node is pointing to. Hence doing the deletion through this really cool trick. So only 2 lines of code, but the insight is kind of tricky. And accepted. Tomorrow I'm gonna do another deletion of linked list, but it's gonna be even trickier than this one. I got it through brute force. I'm gonna show you guys my solution. It has like almost 30 lines. And then there is a cool solution that it's 3 lines, and it gives you an idea how smart people are and how much you have to work to get better at those problems, because they are pretty hard. You gotta learn a lot of tricks. So that's it, guys. Hope you guys enjoyed.